We are literally at the end of this unit. Not literally, because you still have the review to do, and you still have that quiz to do. So, we're just gonna get started. This is lesson 5. This is solving rational. And the great thing about this unit, if you haven't figured it out already, you start to realize that algebra 2 is pretty easy, right? So you just have to check in, tune in, and make sure you're doing the things you should be doing. So we're gonna start with two distinct problems. So when we have to follow rules where we have to simplify, multiply, divide, add, or subtract rational expressions, there's no equal sign, okay? And it changes how we approach the problem. So if I were going to approach the problem 2x plus 3 plus 3x, 2x plus 3, the quantity of 2x plus 3 divided by 8 plus the quantity of 3x divided by 8, we'll be adding at this point. And the denominators are like denominators, so it'll be equal to 8 on the bottom, and then 2x's plus 3 plus 3x's. All right? And we simplify. This equals 5x's, 2x's plus 3x's, 5x's, plus 3 divided by 8. So this is going to look a bit different when there's an equal sign and not some operation between the two rationals. So what we do is we can cross multiply. So if I cross multiply, that means on one side I would write 8 parentheses 2x plus 3. Alright? On the other side, I could write, and I always need to bring down my equal sign, right? 8 parentheses 3x, right? So I cross multiply. I'm doing something called cross multiplying. And if I have a number on one side, the same number on one side, or the same expression on one side and the same expression on the opposite side, it can go away. This goes away, and I'm left with 2x's plus 3 equals 3x. Okay? Now I can solve for x. I'm going to subtract. I'm going to move the x's, the x terms. I want them all on one side. That leaves me with 3 equals 1x. Now, there's multiple ways to approach that particular problem, but we arrive at two different answers. When we're working with an equal sign, we're expected to cross multiply. Okay? Now, if we were adding, subtracting, multiplying, or dividing, we're combining two expressions. So you be quite careful and realize that this is the same as dividing. So another way we could approach that problem, we could rewrite it. Right? So this is the same as saying 2x plus 3 over 8 divided by 3x over 8. And what we know from before is we're switching these. We're taking the reciprocal here. So 2x plus 3 over 8, we flip it over times 8 over 3x. This goes away, and I'm left with 2x plus 3 over 3x's. So that's another way of doing it, but I prefer if you didn't do it that way and just simplified. Okay. So I'm probably going to cut that out the video. All right, moving on. Number 1, cross multiplying. I'm solving the rational expression. So I'm cross multiplying. So 10x times 1, 10x times 1 equals 10x times x minus 5. All right? So 10x times 1 is 10x equals 10x times x, 10x squared. And then 10x times negative 5 is negative 50x. I'm going to add 50x's to both sides to separate, to get like terms on one side. All right. From left to right, 60x's equals 10x squared. So what can I divide out of each term? I can divide an x out of each term. All right. This is going to give me 60 equals 10x. Now my goal here is to get 10 by itself, x by itself. So I divide 10 on both sides, and I get that x equals 6 as my final answer. Okay. Next, cross multiplying here. So x squared plus x times x minus 1. So in fact, I'm going to factor this x squared plus x. So factor x out, I get x times the quantity of x plus 1. So I'm just going to rewrite that. And then the other x plus 1 comes up top. All right. So on the other side, I'm going to factor, going to cross multiply right here. And I have equals 2 times x minus 1. All right. What I have on one side, I can cancel from the other. That's what the equal sign allows me to do. I'm multiplying all these terms. So I have x minus 1, I'm multiplying it on the left. X minus 1, I'm multiplying it on the right. So that goes away. I'm left with x times x plus 1 equals 2. Have x squared plus x equals 2. I'm going to subtract 2 on both sides. Get x squared plus x minus 2 equals 0. So now I can factor it and figure out what the possible answers are. And we're going to have to be careful when we're factoring. So I have, this factors out to be x minus 1 times x minus 2. I think that's right. No. X plus 2. So which one is right? Which one's correct? So using the factors, this first factor, I know that x equals 1. The second factor, x equals negative 2. So I need to check and see which one is extraneous. So I'm going to check. So checking my first side, does 1 squared plus 1 over 1 minus 1 equal 2 over 1 minus 1? Well, does 2 over 0 equal 2 over 0? Yeah, it's undefined, but it works. You check the next one. Does negative 2 squared plus negative 2 equal 2 on top? And does 2 minus 1 equal 2 minus 1? So we're going to look at the difference between the answer before, our check before. So this check, and then, so this is the check when x equals 1. And what's the difference between what's going on here? Okay, but let me finish. So I have 4 minus 2 over 1 equals 2 minus 2. 2 divided by 2 minus 1, right? So that's 2 equals 2. Okay? So this is true. So both of these are true. Both of these situations are true, but there's one that doesn't work because it produces undefined on both sides. So this is extraneous. So x equals 1 is extraneous. It is not a part of my answer. Truly, the only number we can use as a solution is x equals -2. It produces this solution with real numbers. We don't want situations where you all have a number and you're dividing by 0. Okay? We do not want to create situations where you have a number and you're dividing by 0. So be careful. Now, the first method to solve a rational equation. The first method. So you want to combine denominators, and that kind of typically refers to multiplication of the denominators, right? So what's the first method for dealing with rationals? Well, the first thing you want to do, you don't want to combine, sorry. You want to factor any denominators. You want to factor any denominators that you need to factor. And there's a reason why, all right? And we're looking to do this. We're looking to find the lowest common denominators, also called the lowest common multiple. So something that makes both denominators the same. All right, so we're only focusing on the left-hand side right now. All right, so if I look, I'm missing x plus 2. So if I multiply it on both sides, I mean on the top and the bottom, like they did down here, you can kind of go into that direction that they want you to go. So number 3, it says multiply the numerator and denominator of each fraction to make each denominator the same as the lowest common denominator. Once all the denominators are the same, set up an equation using the numerator of each fraction, and then you solve for x. So I like the way this is set up. So first, we're going to go through the rules with a problem. Then you solve. So let's go ahead and solve. So I distribute 15. This is 15x's. Distribute 15 again, plus 30, plus 9x squared, minus 7x equals 9x squared, plus 18x. All right, now I'm going to put everything on one side, I guess, maybe. I don't know. But let's take care of the 9x squareds first. So I have 9x squared, subtract 9x squared on both sides, and it just goes away. All right, so I'm done with that. Now, let's combine our x terms. I have 15x's minus 7x's, that's 8x's, plus 30 equals 18x's. Now, getting rid of 8x on this side and moving it over becomes 30 equals 10x. Divide both sides by 10. X equals 3. Now, you check back with your original equation, 15x, and we check our answer. Does this equal 9? Well, 15 over 3 plus 9 parentheses 3 squared minus 7 parentheses 3 divided by 3 squared plus 2 times 3 equals 9. Is this true? Well, I get 5 here. 15 over 3 is 5. On the top, I get 27. Sorry, that's incorrect. 81. 9 times 3 squared is 81. Minus 21 over 9 plus 6. This equals 5 plus 60 over 15, or 5 plus 4 equals 9. So this does equal 9, so that the solution is appropriate. So we went through a lot of stuff here. All right. I don't want to do method 2. Yeah, I like when all denominators are the same, but we do have to go through this. So to solve for 15 over x, we should still get x equals 3. So we're going to see what works. All right. So first thing to do is factor any denominators. All right. We find the lowest common denominator. Okay. So that's good. Then it says multiply each fraction or term by the lowest common denominator and cancel out what you can. This will get rid of all of the denominators. I don't really like this method. It's super messy, but you know, I'll go with it. So I have 15 times x plus 2 plus 9x squared minus 7x equals 9 times x plus 2, right? Distribute, I get 15x plus 30 plus 9x squared minus 7x on one side, and then I get 9x squared plus 18x, and I'm back to where I started before. And when I solve, I get x equals 3, right? So that's another method where you're multiplying and doing all this extra stuff. I like the first. So we're going to go through the steps that I like the best, which is method 1. And this is where I get denominators the same on the left and the right, right? Number 2, denominators go away. Only when they're the same. See, I'm more confident when I'm saying things in the language that I want to say. So I'm hoping you develop those same skills. So how do I get these numbers to be the same? Well, multiply 5 over 5 over here. Multiply 4n's over 4n's on the right. That's going to give me 5 parentheses n minus 6 over 20n's equals 8n on top over 20n's. When they're the same, denominators go away. That's basically what method 1 does for you. And then you just solve for x. Right? So when they're the same, they just go away. And I'm left with 5n minus 6. So I'm going to have to distribute here, right? And then get n terms on one side and number terms on the other. Right? So subtract 5n's on both sides. I get negative 30 equals 3n's. Divide both sides by 3. And n equals negative 10. All right. Next problem. I want everything to be the same. So I see x, I see 3, and I see 3 times x. So that means here I'm going to multiply 3 over 3. That's what's missing. And here, x over x. And the last one, I don't need to do anything. So that gives me 3 times 1 is 3 over 3x's. Plus 1 times x is 1x over 3x's equals 8 divided by 3x's. When all your denominators are the same, 1 goes away. So I get 3 plus 1x, thank you, equals 8, right? Then I subtract 3 on both sides. 1x comes down, 3's go away, and I'm left with 5. Your answer is x equals 5. Okay? Next. So we check our notes really quickly. The goal here, get the denominators to be the same. Once the denominators are the same, they go away. And then you solve for a variable. So here, I want 3x's all the way across. So I'm going to multiply 3x over 3x, right? What happens? It becomes 3x divided by 3x's plus, I'm not ready to factor that yet, but just write the polynomial, divided by 3x equals x minus 6 divided by 3x. Okay? Now, all my denominators are the same. So they're all going to go away. Right? 3x plus, and now I'm going to factor this. I'm looking for two numbers that multiply to 24, add up to -5. So x minus 8 times the quantity of x plus 3. Right? So I'm just going to write that x minus 8 times the quantity of x plus 3. Do I need to factor this, Miss Smith? Nah, let's just keep it as it is. I thought maybe it's a good idea. But when we're doing these, when we're solving rationals, unlike adding or subtracting or multiplying and dividing, let's just keep it as it is for right now, right? So x squared minus 5x minus 24 equals x minus 6, okay? Now I'm combining like terms. So 3x's minus 5x's is negative 2x plus x squared minus 24 equals x minus 6. Now we want everything on one side and we want it in standard form. So we're going to subtract x and add 6 on both sides. Subtract 1x, add 6. Okay? This becomes negative 3x plus x squared minus 18 equals nothing, equals 0. All right, both of those cancel. Now I want to put this in standard form, figure out what are my two factors that make this polynomial true. So two numbers that multiply to negative 18 add up to negative 3. This equals x minus 6 times x minus 3 plus 3. And my numbers here will be x equals, curly bracket, two numbers, 6 and negative 3. That's my numbers. Okay? Then it says try these and then check them in your calculator. The way that you try these and check them in your calculator is you write the original function. We're going to check each side and see if it's true. So my original function, we're going to check to see, does x equal 3? And does x equal 6? Alright? So, I'm going to go plug these in. I'm only going to do this once, so second mode. So first I want to check, does x equal 3? So 3, store x. I'm storing 3 into x, and then I'm just going to type the function in, the left side of the function in. So on my left side, if I look back at the problem here, I have 1 plus alpha y equals, enter, 1 plus x squared minus 5x minus 24 over 3x. What does it equal? Well, this side, left side, equals negative 7 over 3. The right side, as long as these two sides equal, then we're in a good place. So alpha y equals, enter, x minus 6 over 3. Just going to make sure I wrote that correctly. 3x. Okay, enter. And I get equals negative 1 over 3. So is that true? So x equals 3 is probably not a solution. So I'm going to check the next one. 6, I'm going to store 6 into x. Not just any 6, I think it's negative 6. Let me make sure these numbers are correct. I'm sorry, that's negative 3. It's negative 3, so let's make a correction. I'm glad I checked. Let's go back and check. Negative 3 stored into x, right? And then I put my first equation back up. My first equation, I type it in, pull it back up, or the left-hand side of that, which is 1 plus x squared minus 5x minus 24 divided by 3x. Enter. And that equals 1 on the left, right? So when x equals negative 3, I have 1 on the left. Does 1 equal the other side? Pull up the other equation. Or you could just type it. 1 equals 1. So this one works. X equals 3 works. Negative 3 works. Now I want to check, does x equal 6? So same thing. Store 6 into x. Pull up my equation. Enter. I get 0 on the left, and then I get 0 on the right. Okay? So both of these answers work. So my final answer here is literally that set of values. Number 4, 5, and 6. Well, let's go ahead and do it. So now we should know we want denominators to be the same. You're going to do number 6. Okay? So in order for these to be the same, I have a 2x, a 4, a 2x, a 4, and an 8. So the biggest I need these numbers to be would be 8. So what could I multiply times 2x to make it 8? Times 2 to make it 8. Well, I could multiply 4 times 2x to make that true, right? Now look at the second one. What could I multiply times 4 to make it 2x? 4 to make it 8x, really. So I can multiply 2x on the top and the bottom to make this work. Now look at the last. What number do I need to get this to work? I need that lowest common multiple to be 8x. So I need an x and an x for 5 over 8, right? And if we did this right, we're going to end up with the same lowest common multiple. Okay? So 4 distributes to x, so 4x, and 4 distributes to 3, that's positive 12. On the bottom, I have 8x's plus 2x times 3 is 6x's over 8x's on the bottom equals 5x's over 8x's. Now, after that, these cancel. I'm left with 4x plus 12 plus 6x's equals 5x's. After that, I have 10x's plus 12 equals 5x's. Subtract 10x's on both sides. 12 comes down, equals 5x, negative 5x. Divide both sides by negative 5. And x equals negative 12 over 5. There's one. Second one, right? Second problem. I need 4y, 2y, and 6 to be the same. I'm going to say the biggest number that I can make these, or the smallest number I can make all these the same, where I can make all these the same, would be 12. So in order to produce 12 for 4y, in order to produce 12, my lowest common multiple is 12 y's, right? In order to produce 12 y's on the first fraction, I need to multiply by 3 on the top and the bottom. So 2y's minus 1 over 4y's, right? Now, how can I produce 12y's with 2y's? You need to multiply by 6 over 6 times 1 over 2y's. And then, for the last one, you need to multiply by y and y. So y and y, right? And it should give me the same denominators. So I have 3 times 2y's is 6y's. 3 times negative 1 is negative 3. Plus 6 equals 4y's. Everything else becomes 12y all the way across. Oh, sorry, that should be 2y's. And change that to 8 here, 8y. All right. Now, combine like terms, I'm left with 6y's plus 3 equals 8y's. Subtract 6y's on both sides. 3 equals 2y. Divide both sides by 2. Y equals 3 over 2. Please do the last one on your own, and that's the end of that. All right, guys. So the next section in this unit is going to be the last section, which is the unit review. You will have a quiz during that, before that review, and the rest of it you have to do on your own. You need to go back and watch videos, and you need to do that. If you haven't completed all the homework, then you probably should do that. You have your best chances at passing the test when 1, you've done all the homework, number 2, you've done the review. Have a great day, guys.